Hey you guys, in this video, basically what I want to do is just talk about a couple of the key ideas that you'll come across in the problems you'll try today for the free response question and the first 5 multiple choice questions. So I'm just going to kind of briefly touch on a few ideas. First, the idea of continuity comes up in these problems. And so first, like continuity at a single point. Um, Basically, the reminder that is any function where if you were to be able to draw it without lifting up your pencil, that would be continuous. Doesn't have any jumps or holes or asymptotes. And so at a specific point, we can show that continuity by saying the function exists, by saying that the limit exists, which means you have to do left-hand limit equals right-hand limit, and by saying that that function value equals the value of the limit. Okay. So a little example here, if we were to try to show that f of x is continuous at x equals -3, this piecewise function here, I would need to show, well, what is the value of f of -3? There should be a negative in there. What's the value of f of -3? Well, for this, I use the bottom equation of the piecewise. That's -2x minus 1, so that'd be 6 minus 1 is 5. And then I have to find the limit from the left and the right. Well, the left would be as x is less than -3, so that would be plugging into absolute value of -3 minus 2, which is absolute value of -5, which is 5. And then from the right would be using the bottom, because it's bigger than -3, -2 times -3 plus or minus 1, which would be 6 minus 1, which is 5. So because those two, the left-hand limit equals the right-hand limit, we know that the two-sided limit, x approaches -3, of f of x is 5. And so I can say that yes, this is continuous because f of x equals 5, which equals the limit as x approaches 3 of f of x. Another continuity type question is when it asks you to find like the value of a in order to make a function continuous. So here I have f of x is x squared when x is less than 2, and ax plus 3 when x is bigger than or equal to 2. So at x equals 2, we should have x squared equal to ax plus 3. And so if I plug that in, I get 4 equals 2a plus 3, and so I can solve that and get 1 equals 2a, or a equals 1/2. Okay. What else? We are going to see a problem that asks about the difference quotient. The difference quotient is a way to just we used it to estimate the instantaneous rate of change. Estimate instantaneous rate of change. Okay, and we would do it, we could do a left-hand estimate, a right-hand estimate. The biggest thing you need to remember is that you basically take an x value, b, and an x value, a, and it's really just slope. Okay, it's average rate of change, but really, really close to 2 points that are really, really, really close to each other. So like maybe you go with a and b to estimate the slope of the tangent line by calculating the slope of a secant line. Finally, you'll see the intermediate value theorem come up. And actually, it doesn't so much come up as you have to use it to answer the question. And so this is that theorem. I think I gave an elevator example maybe. Basically, if you started on the 2nd floor, got on the elevator there, rode it up to the 23rd floor, and got off the elevator there, you would have had to pass every single floor in between. And that's what the intermediate value says, except for functions. Remember, that would be like saying if we knew a function started at a particular y value purple here, and ended at a particular y value from a to b, and we knew it was continuous over that time, then it's got to pass every single y value in between f of a and f of b. And so to kind of prove a problem like this, or to solve a problem like this, you want to make sure you state what the actual value is of f of a, what the actual value is of f of b, those two y values, and you can show that any y value in between would be reached. You could solve for it if it asked you to. And the biggest, most important thing is if it's a free response question, you have to mention that it's continuous, because the intermediate value theorem does not work if it's not continuous. Okay, hopefully this helps out on those problems, and let me know if you have any questions. Thanks.